At 6:15 in the morning, just offshore from a quiet beach near Riposto, on Sicily's eastern shoreline, the Mediterranean began to roil like a boiling cauldron. Early visitors froze in disbelief as the water churned violently, sending thick plumes of steam nearly 20 feet into the air. Within minutes, the surface temperature surged from 68 degrees Fahrenheit to a blistering 170 degrees Fahrenheit. A tourist captured the surreal scene on video as the sea appeared to boil, and within hours the footage had gone viral, igniting alarm and fascination among communities that have lived for generations in the shadow of Mount Etna. This is not the first time Etna has reminded residents who truly commands this island. Yet what is unfolding beneath the surface now hints at a phase scientists say has never been documented in recorded history. Mount Etna ranks among the most active volcanoes on Earth, erupting almost continuously for roughly 3,500 years. The volcano has shaped Sicilian life, culture, and survival for millennia. Lava flows have destroyed villages, ash clouds have grounded flights, and earthquakes frequently rattle homes. Still, Sicilians have adapted, cultivating crops in nutrient-rich volcanic soil and planting vineyards across ancient lava fields. Etna's eruptions usually follow familiar patterns. Magma rises, pressure mounts, and lava bursts from summit craters or tears through fissures along the flanks. Scientists track tremors, gas emissions, and subtle ground shifts to forecast activity. That monitoring network has protected countless lives. What is happening now defies those established patterns. The boiling seawater emerged without warning. No significant earthquake signaled its arrival. No lava spilled from the summit. Thermal readings at the craters appear normal. GPS instruments show no unusual ground deformation. Yet the ocean itself is heating to extreme levels. Volcanologists from the Italian National Institute of Geophysics and Volcanology rushed to the site equipped with thermal imaging devices and gas detection instruments. What they uncovered forced a reassessment of the region's volcanic risk. Newly formed underwater vents are releasing superheated volcanic gases straight into the sea. These vents were not present just weeks ago. They appeared suddenly, breaking through the seabed along fracture lines that stretch from Etna's eastern flank into the Ionian Sea. Gas temperatures exceed 1,800 degrees Fahrenheit at the point of release, hot enough to melt lead and instantly vaporize seawater. Remotely operated submersibles sent down to investigate captured footage that left researchers stunned. The seafloor is fractured like shattered glass. Pulses of glowing magma move just inches beneath a thin crust of cooled rock. In several areas, fresh lava seeps directly into the water, generating towering columns of steam that surge to the surface. This is not a typical eruption venting upward. Instead, magma is traveling sideways underground, migrating away from the main volcanic cone and carving new escape routes. The entire eastern flank of Mount Etna appears to be fracturing, and the sea has become its pressure valve. Geologists have long worried about this possibility. Etna rests on unstable foundations. Its eastern slope gradually creeps toward the sea at roughly 1 inch per year under the immense weight of accumulated lava and ash. That slow movement places tremendous strain on the rock beneath. When stress exceeds the strength of the bedrock, cracks form. Magma surges into those openings like water through a breached dam. If sufficient magma intrudes laterally, the eastern flank could potentially detach and slide into the Mediterranean in a catastrophic landslide. History offers a chilling comparison. When Mount St. Helens erupted in 1980, its entire north face collapsed, unleashing a lateral blast that flattened 230 square miles of forest. But St. Helens is inland. Etna rises along the coast of one of Europe's most densely populated islands. Its eastern flank faces open water. A major collapse there would send millions of tons of rock crashing into the sea, potentially generating a powerful tsunami across the Mediterranean. Some models suggest waves as high as 30 feet could strike Sicily's shores within minutes. Southern Italy, Malta, Greece, and parts of North Africa could face destructive surges with minimal warning. Officials maintain that monitoring data show no immediate signs of flank collapse and emphasize that the mountain remains stable. Yet the boiling sea tells a more unsettling story. Marco Bellini, who operates a diving tour company in Taormina north of the affected zone, watched his business vanish in a single morning. Few tourists are willing to dive in scalding water. Summer bookings were canceled almost overnight. Hotels report a spike in cancellations as visitors opt for safer destinations. The Italian Coast Guard imposed a 1-mile exclusion zone around the affected waters, prohibiting boats from entering. But that boundary continues to expand as new vents appear. Each day, additional fissures open along the seabed. The area of superheated water spreads farther along the coastline, edging closer to popular beaches. Marine biologists surveying the region have documented major ecological changes. Water samples reveal elevated concentrations of sulfur dioxide, hydrogen sulfide, and carbon dioxide dissolved in the sea. These volcanic gases increase acidity and alter the delicate marine balance. On land, high levels of hydrogen sulfide could pose health risks if shifting winds carry plumes toward coastal towns. Local authorities have quietly issued gas masks to emergency personnel and installed air quality monitoring systems in nearby communities. These measures are not widely publicized. Tourism accounts for roughly 40% of Sicily's economy, yet rumors travel faster than official reassurances. Residents see steam columns rising each morning. They smell sulfur in the air. They remember stories handed down through generations about the mountain's unpredictable power. Researchers mapping the seafloor have identified fracture patterns stretching for miles, tracing fault lines that radiate from Etna like veins from a beating heart. The magma is not ascending toward a dramatic summit explosion. Instead, it is spreading laterally, filling every available crack beneath the coastal bedrock. This sideways intrusion creates mounting pressure. As molten rock accumulates underground, stress intensifies against the already unstable eastern slope. Each cubic meter of magma adds weight and strain. The forces involved are enormous and unyielding. Eventually, something must give. Engineers cannot brace a volcano. Authorities cannot evacuate an entire coastline indefinitely. Scientists cannot pinpoint the exact moment when geological stress might trigger catastrophic failure. They can only continue monitoring instruments, tracking expanding thermal signatures, studying seismic readings, and watching the restless sea. For now, the Mediterranean speaks in steam and bubbles. Beneath the surface, the mountain shifts in darkness. History suggests that this ancient volcano is unlikely to settle quietly.